Hi, welcome to this lesson on number patterns, finite geometric series. Here we're going to be looking at question 3 on solving a finite geometric series problem. Here we are being asked to show that the series 32 plus 16 plus 8 all the way up to this nth term, 32 times a half to the power n minus 1, can be written as this formula here. S sub n equals 64 minus 2 to the power 6 minus n, where n is a natural number. So let's see. First of all, let's confirm this is a geometric sequence of this form. A times r to the power n minus 1, where n is a natural number. Well, here my first term a is 32. And if I see from 32 to 16, I'm multiplying by a half. From 16 to 8, I'm multiplying by a half. And so on. So therefore, I would say my common ratio r here is a half. And we can actually see that the last term they gave us is actually the general term for this geometric sequence, right? It is a, which is 32, times r, which is a half, to the power n minus 1. So that does denote that that is the nth term of that geometric sequence. In this case, the geometric series ends at the nth term there. Okay. So because my r is a half, that's less than 1, I'm going to use the second formula. So therefore, recall the sum of the first n terms of a finite geometric series is a into 1 minus r to the n all over 1 minus r, where n is a natural number. Okay, so I know what my a is, I know what my r is. Okay, so let's go and put that in. Therefore, Sn equals 32 into 1 minus a half raised to the power n all over 1 minus a half. So now we've got to clean this up here and make it look like this here, which I've asked us to show that it can be written like that. So my numerator, all I'm going to do is change the half to 2 to the power negative 1. That's using exponential laws, right? The reason I'm doing that is because I see in the expression there's a 2 and there's a negative n there in the exponent. So that's why I'm first making that change there in the numerator. 1 minus 2 to the negative 1 raised to the n. And the denominator, 1 minus a half is just a half. When you divide by a half, you're multiplying by 2, right? When you divide by a fraction, you tip and turn, you multiply by the reciprocal. So the reciprocal of a half is 2. So 32 times 2. And that's times 1 minus. Now, exponential law says when you have a base with an exponent raised to another exponent, you multiply those exponents. Negative 1 times n is just negative n. So that becomes 1 minus 2 to the power negative n. We're almost there because we almost have it looking like that. Now 32 times 2 is 64, and that's being multiplied into 1 minus 2 to the negative n. Well, now we've got to distribute out here. So 64 times 1 is 64. It's already looking good. I've got the first number there in that term. Minus 64 times 2 to the negative n. But that's not what's here. But that expression is telling you exactly what to do. You wanted everything as a base of 2. Now 64 as a base of 2, recall. So we know 64 is 8 squared. This is the logic I use. And 8 is 2 to the power 3. And that's to the 2. So 64 is 2 to the power 6. She multiplied the exponents here. So I can rewrite this as 64 minus 2 to the power 6 times 2 to the negative n. But lastly, exponential laws say I'm multiplying these two bases which have the same base. Therefore, I must add the exponent. So I get 64 minus 2 to the power 6 plus negative n, which is just 6 minus n. So, can you see how important your exponential laws, the knowledge of those, have to be here in order to do the geometric series problems? Because geometric in its nature is exponential. That is why we've been harboring on all these years about exponents, because it leads into this more complex stuff. Okay, and that is how you would solve this type of problem. I'll see you in the next one.